going to start by looking at parabolas and conic sections, and the main equation for parabolas is y equals x squared. You plug in 0 and you get 0, 0. That's going to be actually the minimum point or the vertex in that parabola. Notice that this parabola is a function because it passes the horizontal line test, but its inverse is not a function because it fails the horizontal line test, and the inverse would look like this. That would be an inverse, not an inverse function. Notice x and y's would be exchanged. There are different forms of parabola. You have the standard form, you have a vertex form, and vertex would be HK, and you have a factored form, which tells you what actually the x-intercepts are. And you also have another form, which is the standard form. And the standard form is two different forms. One is for the vertical orientation, and another one is a horizontal orientation. The forms are developed by the definition, and the definition of parabola is all the points in a plane the same distance from the focus and the directrix. So what that means is this is actually a directrix, and this would be a point on the parabola, and all that's saying is that this distance is the same exact as this distance. So you have a focus, which is this point, you have a directrix, which is this line, and you have points on the parabola. Now, the p is really important here if you put it in this form. It's 4 times p, and p is a letter which is going to be the distance from the vertex and the focus, and also the vertex and the directrix. So it's not the best diagram, but really you have p here and p here, and you would know if p were positive in this case, it would go up. If it's negative, it goes down. When you're squaring your y, p is positive, it goes to the right. P is negative, it goes to the left. All of those are really important. Now, there is data that you can use when you're talking about the vertex, focus, axis of symmetry, directrix, but I find this more confusing than helpful. The main thing is know your general orientation and know that p is the distance, again, between directrix and vertex and focus. I want to start doing some problems here. The first thing is that I'm going to realize that this is going to be a graph, and it's going to be y squared, and I also know that it's positive p, so I know somewhere it's going to open like this to the right. The vertex on this particular problem is going to be where your x is 3 and your y is -1. So that's a main point on this graph. And so we're going to go ahead and plot that point. I know it's going to open to the right, and I know what my p is because I can rewrite this, or I could write down 4p equals 8, and therefore p is equal to 2. So this graph is going to open like this somewhere, and I know that the directrix is going to be this way, and the focus is going to be over here, and I know that this distance from here to here is going to be 2. So I know that the directrix is x equals 1 because it's 2 off of 3, and I know that the focus is going to be point negative 5, actually 5, -1. So it's going to be 5, -1 on the focus. Again, this distance and this distance are going to be the same, which is 2. And therefore you have the directrix, you have the vertex, you have the focus, and the axis of symmetry would just be y equals -1. Don't need to worry about that too much. This one, I see that my x is squared, so I know it, and the p is positive. In fact, p is equal to 1. Again, you could say 4p is equal to 4, and p is equal to 1. The vertex is equal to a -2, 1. So again, you're going to be looking at putting in that vertex and labeling it. And again, it's going to be going up because your p is positive and you're squaring your x. And now you can go ahead and label the different parts. Now, p is 1, so I'm going to go 1 down here. Therefore, this is actually going to be the directrix. So that's where y is equal to 0 as the directrix. And your focus point right here is going to be where it's 1 up from here. And that means that it's going to be a -2, 2 on the focus. And the vertex is labeled down here. Now, as you go through these problems, you may find that you have a situation where it is not in that standard form. And when it isn't in standard form, you have to put it in standard form. To do that, you have to complete the square. And so I'm going to rewrite it as your squared term on the left side and your regular term on the right side, or term to the first power on the right side, and then you want to complete the square. Divide -8 by 2 is -4. Squaring it is 16. I want to add 16 to both sides. Now you can complete the square. And then the last part of completing the square is you know that you have to have a 4 out in front of this y minus 2. But it's really equal to 1 out in front in this case. If not, you'd have to you may have to factor a number out, but because it's 1, that you have to put a 4 here, and 4 times 1/4 equals 1. You can always figure out what this is, because you could always say that 4 times p is equal to that 1, and p is equal to 1/4. And therefore, now it's in the right form that you can go ahead and graph. So you want to strive to put it in standard form, and then you can go ahead and find the particulars. So that's a summary on how to graph parabolas, what the definition of a parabola is, and finding some of the details after you get standard form.